In this section of my Blender to SFM transition series, I will show you how to create complex rigs that will work in SFM. The first step in rigging a complex model, especially one containing pistons, cables, or deeply nested armatures, is to decompose the asset into simple static elements. These elements are intended to be driven entirely by single bones, forming a clean and predictable control structure. Alongside these static components, a primary base rig is established. In character workflows, this typically corresponds to the body or core deformation rig. I will make the core rig based on two bones, one for the base of the piston and one for the ending of the piston. In edit mode, I make sure to set my origin points correctly to add the bones with control a shortcut in the correct places. The animators who use this rig will be very thankful to the riggers without knowing it. Extend the tail of each bone in an appropriate place to make using it in Blender easier. Rename the bones in this tab. Make sure you are in edit mode doing so. Parent the mesh to the armature with empty weight groups. We will assign them by ourselves in edit mode. With transparency enabled, select all vertices like so and assign selected vertices to the bone we named earlier. We can also add root bones that aren't linked to any mesh selections. As long as other bones they are parented to it, they serve a crucial function in the rig. For this demonstration, the base mesh is a simple piston. Due to its straightforward geometry, the weighting process is intentionally minimal. A full influence of 1.0 is assigned to the vertices at the top of the piston, and a full influence of 1.0 to the vertices at the bottom. Each region is controlled by its own dedicated bone. The next step is to add all basic static elements to the main rig. This would normally take the fastest users 5 minutes of work, so I wrote a script that does it with one click. My scripts are available on my Discord server, linked in the description. Run HoovyTube's bake meshes as rig bones batch script to convert all selected meshes to the clicked armature. Press Alt-P to run a script. The script automatically parents newly created bones to the nearest existing bones based on proximity. Because of this, it is recommended to switch to Edit mode after the process completes, unparent the generated bones, and then manually rebuild the parent-child hierarchy. This allows you to define a clean and intentional rig structure that matches the mechanical or logical relationships of the model, rather than relying on automatic proximity-based connections. I will perform this for all bones using the parent make parent function. The next step is adding the pistons as bones to the main armature, but removing weight influence from their tips and assigning it to the drill attachments. First, we will run the script from the previous step to add them all as bones. Whenever we manually change the weight of vertex groups of bones parented to an armature, we need to detach it and reattach it to the armature to update our changes. Now, we can add an influence of 1 to the vertex group that matches the bone that controls the drill. The last step is rigging the cables. I will begin by joining all of them and adding them as a single bone that I will parent to the tip of the main piston. To change the origin point of a mesh, press Ctrl and dot. Press it again to return back to moving meshes in the object mode. Now I will create a new vertex group called cable end that will be parented to each corresponding drill rotator. Paint a selection in the weight paint mode. The smoother it is, the better the final outcome will be. Now, run HoovyTube's Bake New Bone to Rig script with your vertex group selected in the Vertex Groups tab. If you use the default settings, you will create a new bone in the cluster you painted in the Vertex Paint tab. If you don't like the result you ended up with, you can manually edit the groups in the Vertex Paint mode. However, if you decide to manually paint them, perform Weights Levels option. That will normalize the influence of every vertex to 1.0 if you run it with these settings. We can also use the second script I mentioned to add jiggle bones that aren't attached to anything. If you run into such issues that the mesh seems to lag behind the rotated or moved bone, it means that the vertex groups aren't leveled to 1. To make the model more user-friendly, I will perform the smooth function in weights with these settings. After performing smooth, I always perform levels with the settings I mentioned earlier just to be extra safe. And this is all you need to know about rigging models intended for SFM. I will quickly port it to SFM using HoovyTube's Monster QC compiler that I already made a full tutorial about, and it is available on HoovyTube's Discord server for free.